and capabilities of the system. The problem is that it's like somebody who just takes their first computer science class and they learn about bubble sort and they say, God, why is my computer so slow? Well, because you're using bubble sort. It turns out that there's new, better algorithms that can be implemented, new, better methodologies and techniques that can be implemented. And what we've been trying to do as an ecosystem is balance speed of delivery to market with time for the development of tooling, pedagogy, and community-driven applications. So if we had all the time in the world, what would happen is you would have a very long testnet period, about a year. And you'd have lots of people come, tons of challenge problems, and there'd be this grand evolution in education of the underlying infrastructure. Now, we're in a competitive environment. There's tons of other protocols. A lot of people are moving very quickly. It doesn't make sense to do a long burn-in. So you can shorten that if you believe there are no safety concerns. And what you can do is create something on the main net where it's clear that there's a certain class of problems that are very easy to solve. And you now add lots of value to the system. And there's a set of other problems that the community is going to struggle with for a bit, probably about 3 to 6 months. And you let them struggle with those problems until those are resolved. So the purpose of this video is to, and it's going to be a little bit of a whiteboard video, is to kind of talk around where we started and where we're going and why Cardano was built the way it was built, and hopefully give you guys some more clarity on some things. So let's get right to it. And then I got to go. Okay. Wow. All right. So the first things first, I wrote a paper way back in the day. I think this was 2016, which is Why Cardano. And in this, I talked a little bit about our design principles, various things that we were thinking about, various things we looked about. And I also talked about kind of two concepts. One was the idea of Cardano settlement layer and Cardano control or computation layers. Okay. So the basic idea is that no matter what computing model that we adopt in the main chain, there's going to be some use case pattern or cost or performance requirement or concurrency requirement that's not satisfied by that. And as a consequence, there's going to be somebody who's unhappy with whatever design change, design idea that we have. So they'd be a lot happier if they lived in a domain that's built bespoke for them. Okay, so the first thing is UTXO for accounting versus accounts. Okay. Now, the problem between these two, and this is hotly debated in the space, UTXO, Bitcoin follows, and there's a whole cohort of people playing around with that. And if accounts is what Ethereum does, it's almost like imperative versus functional. You know, functional programming language like Haskell versus imperative language versus JavaScript. There's just going to be radical differences of opinion about software design, development, accessibility, and what's the right tool for the job. So when we designed the system, we said, can we construct something that makes it easy to spawn off side chains that have different computing models? Okay, and different utility for the system. So for the purpose of this lecture, there's really three. Yella, the EVM, and Catalyst. Okay. So Catalyst is all about consent and a complex collection of voting protocols. Now, if these voting protocols were to be developed with traditional EVM or Pluto-style smart contracts, they'd be extremely expensive and heavy. So they're basically built into the chain. Okay, and there's a lot of MPC and all kinds of stuff going on here. And this is basically what we've been doing with Catalyst as a standalone chain. Now, the EVM, many of you watching who are Ethereum developers, you're familiar with this model. The whole Web3 concept, all the different libraries you like to use, all the different tools you like to use, all the layer 2 solutions. This is a vibrant ecosystem, and there's a lot of growth. And there's a lot of software that's already written there. And you guys are pretty comfortable with that. One of the big problems, though, is scalability here, principally because you have global concerns for the model to work. So basically, everybody has to know each other's business. The UTXO world, you have local concerns. You really only have to know your part of that graph to be able to do the things you want to do, and you preserve inclusive accountability. So when you want to do things like shard and scale, you want to do off-chain stuff, you have a lot of non-determinism. Here you have absolute determinism. And you have a lot of concerns of exactly how to address that, deal with that. This is one of the reasons why Eth2 is such a complex piece of software and why they're having such trouble getting these out. This is not an easy problem, and kudos to them for thinking about it and trying to solve it. However, because you have global concern, you have a slightly easier time as long as you're willing to accept these trade-offs with things like concurrency and things like event handling. But at the end of the rainbow, almost all the solutions that actually in practice deal with this because of cost and scale, they have to deal with this as off-chain, some sort of layer 2 or centralized solution. This is why a lot of people actually, when they say DeFi, they say, actually, we're talking about CeFi. Because in practice, to make these things cost effective and scale, we actually need to introduce some centralized components. Okay. Now, Yellow is a different thing. Yellow is actually a register-based assembly, and it's based on LLVM, which is a very well understood model that came out, I believe, in 2003. And it's really built on top of the entire K stack, K technology stack. And this has always been something that I've really liked and wanted to enjoy. The concept here is really universality. K has always been a kind of a meta programming language. So really the idea is something like the JVM or the CLR, something that is sufficiently complex enough that we could actually have a real conversation with a straight face about eventually C support and C++ support and other mainstream languages, and have a path and a process to basically get there. Hang on a second. All right. So let me just kill that real quick. So the point of the settlement layer and the way that Plutus and extended UTXO were designed is we had some principles with this. We said, okay, well, there's going to be these different computing models, specialized computing models for governance that are very, very heavy and resource intensive and run very deep protocols that cannot be replicated with the standard smart contract model, even with UTXO and all the optimizations we could potentially do there, or with this account-based model with Ethereum, or anything we can do in Yella. If we want to copy Ethereum, we need a special sandbox to do that and allow that to co-evolve with how Ethereum evolves. And if we want to chase new concepts like Yella, which is a new concept to the industry, and all the power that K gives us, and we want to chase universality, then we're going to need some sort of connection point for that. Okay, so the first goal of Plutus was really pushing for CSL to CCL interoperability. Okay, so basically the idea is that assets, information, users have a easy method of flowing between the different systems and calling between the different systems. So as sidechains turn on, you can do your computation off the main chain. You can do it inside the computation layer. For that, you can call it, and then results can flow back and forth. Here, this kind of is beating at a methodical pace. Okay. So basically, you have a block every so often. It's like a heartbeat. And that's your unit of change. And these unit of change, they can be batched, You can get much more efficient. You can compress things. You can use compressed representations. You can do things like, for example, be very clever. You can use NFTs for access control. There's a lovely blog post floating around about this. Okay. And then in terms of concurrency, you can actually distribute amongst many UTXOs. Okay. And then you also can do off-chain processing, like Ethereum does in practice. But you can't get around the fact that there's a consistent, reliable, semi-synchronous heartbeat that the system has. This is a fundamental design principle of most blockchain systems, Bitcoin, Ethereum, other things. And there's all kinds of things you can do. There's all kinds of things you can do to make things more efficient, to be more clever about resource utilization, and how you represent information and what you're actually processing on chain, about how people have right of access and how access control is going to work, and how distribution amongst the UTXOs is going to work. But you still always, regardless of the blockchain system you're using, if you choose to use a block-based system for change, you're going to have this methodical pace, this flow that happens. Now, you can get very clever and you can put some pre-processing into the stake pools, and they can do all kinds of things to handle event flow and concurrency before some change gets committed. Or you actually can run things in a dedicated channel. And this is kind of the idea of Hydra. Hydra says, oh, okay, so we're going to have stuff that happens on chain and off chain. All right, well, that's actually starting to get sensible. So we have these things that are occurring, and somewhere around here, we're going to go into this kind of domain. It's going to have lots of users interfacing with the domain. They're going to have a lot of fun. And then at some point, those changes get committed as a single batch transaction on chain. Now, you can do such a thing if you've designed your accounting model and your programming model, as we did with extended UTXO and Plutus, to work with the layer 2 solution. One of the reasons why Lightning is having a lot of trouble with this type of process is that the programmability of Bitcoin script is extremely limited. Plutus is actually a general purpose programming language in a certain respect. It's a DSL that looks a lot like Haskell, and it is Turing complete. Now, the thing about it is that when we're doing this, you build this like a spiral. And I'll show you where we're at. So when we started this, it was just good old fashioned push transactions in Byron, just like Bitcoin. And then we started adding some more sophistication. We added in metadata. And then suddenly you can put payloads into the transaction. And this enabled things like the Ethiopia deal and beef chain, and a litany of other things like supply chain management. Why? Because you can now embed into the transaction metadata that the system doesn't care about, but your application does care about. So DIDs are the canonical metadata. Identity travels on the wire. Then you have, next step, user issued assets. So the Cardano native asset standard. And what are you guys doing? You're issuing tens of thousands of NFTs, because that's right now the level of sophistication our native assets have. And now we actually have the next step where we're introducing on-chain Plutus smart contracts. Okay, and this is huge because first off, it allows the interoperability bridges to occur. So when sidechains start materializing centralized and decentralized, you can start moving assets, information, and users between them, including Ethereum sidechains. Okay, so all that stuff you guys are used to in that world, it now can work. Okay, so you have interoperability enabled. Okay, you have things like spending policy. So you can issue significantly more for tokens. You can issue significantly more complex tokens, not NFTs, which are kind of passive things. Now you can do things like a stable coin. So you guys may have seen the DJED paper, the paper on an algorithmic stablecoin. This is an example. You can now use Marlowe. So that's going to be rolling out as the PAB gets integrated and these things get worked. And so basically now you can have very complex financial contracts. But because they're written in Marlowe, they're simple to write and they enjoy determinism. So you understand your resource costs, security. They enjoy safety and execution and a litany of other things. Okay. Now there's open questions about, well, what about DEXs? Well, yeah, you can do DEXs. And actually, one of the DEXs in the ecosystem, Akamfi, wrote 2 articles. One was in July saying, hey, we're thinking about concurrency, and they kind of talk about some of the challenges. Then they read another article, just came out today, 2 weeks ago, August 18th. They say, actually, we're ready for concurrency. We figured it out. You see, and why? How did they figure it out? Well, there's a lot of different ways to do it. And I probably am guessing that they are using some sort of off-chain batching mechanism and event handler and serializer to accommodate that, and then efficiently committing things once they've settled on the off-chain infrastructure, on the on-chain infrastructure. And that's okay. That's actually how Plutus was designed. Stuff happens on-chain, stuff happens off-chain. You can write both. You can think carefully about both. Some solutions are somewhat centralized. Some solutions are not centralized. But guys, your imagination is limiting you if you think that, well, we can only do one thing every block pace. No, you can either distribute the UTXO, or you can be very clever about using off-chain infrastructure for batching, or we can introduce more complicated concepts over time. That's the point of the spiral. You see, here we're safe. We've achieved something that's amazing. Smart contracts on a UTXO model. Had Bitcoin had this capability, Ethereum would not exist. That's what we basically did. We solved a 12-year-old problem that Satoshi couldn't solve, and we brought that into the UTXO model. This is a safe programmability of UTXO. But that doesn't mean that that particular solution is the end-all be-all, because there's going to be all kinds of patterns like oracles and dexes and other things that need to be thought carefully about. And there's always going to be this balance of what do you run off chain and what do you run on chain? And that always comes down to concurrency, operating cost, and it comes down to security and trust. Okay. These are your factors. Whether you're Ethereum or Cardano, you have to think about this as an application developer. Oracles, for example, you could do completely on-chain oracles and make them completely deterministic. That means all that data has to be committed to the chain. So, for example, let's say the price of ADA to USD. Well, what if you're doing that every block? You're adding an enormous amount of bloat to the system. Well, you could do a completely off-chain system. All right, well, that's a different trust model. Maybe you federate it to improve the model. Maybe you introduce bonds or other mechanisms or punishments to improve the veracity of the model. You see, but then it's all about access to that off-chain. Can a smart contract query it and talk to it? We have to build some mechanism for that. So you need some sort of bridge for it. Oh, okay. Well, these are design considerations that you have when you actually put an oracle together. The same for a DEX. Where is the batching happening? The batching and matching. You can always choose the bubble sort and use the slowest possible method and say, oh, yeah, the way I wrote it, only one transaction can happen per block. Sure, that's absolutely possible. You also can come up with very clever off-chain ways of doing it. Now, as we get a little further along and we add the computation layers, what gets really exciting is you now have emergent interactions. Okay. So, for example, you can have an EVM style smart contract. And that EVM smart contract can now call and talk to a Plutus contract and vice versa. So maybe it's easier in your mind to do the batching and matching and these other types of things on an account based model because you just understand that and you want to do that. Great. You can leave the value here and use this as the control contract that actually handles it with all the user interactions. Well, what's our advantage over Ethereum? Well, one of the really cool things about having a root of trust is this is the single most expensive thing to establish in a cryptocurrency. Proof of work does this for Bitcoin, and it costs billions of dollars every year and massive amounts of electricity. Okay. But once you have that root of trust, you can then use it as a guarantee and then build efficient light infrastructure above it. Okay, so I'll give you an example. Right now, Ethereum uses proof of work to establish the root of trust. They're trying to move to a proof of stake system because they know once they have that, they can shard and have different computation domains. Starting to look like a Cardano style architecture now, isn't it? Well, wait a minute here. We have Ouroboros. And right now we're running Prouse. This year we'll likely upgrade to Genesis, and then we'll do a little bit of optimization to that. But once you have that as our root of trust, why can't we run OBFT, a significantly faster protocol that presumes a trusted quorum, and use the SPOs as the quorum? Well, wait a minute here. Now we're running a BFT protocol. These things have been shown to operate in the 1,000 TPS or better range. And there's papers like Rapid Chain that talk about how to shard OBFT. Plus, you can run them concurrently, right? Because you can use the same SPO set to run many different chains. Sorry, my pen is acting up today. So you could run copy 1, copy 2, and load balance and so forth. Well, that's actually quite easy to do. And we have something called Mamba that we've been working on specifically for Ethereum support and ELA support. And we're going to talk about that at the conference on the 25th. And you betcha we're definitely looking at using OBFT led by the SPOs. Okay. So if you're running much faster and you don't have to worry about the selection of the people, you have a stable quorum, you can highly optimize, and your trust model is actually reduced to the trust model of Ouroboros. So you're not actually changing the underlying trust model that we already have for Cardano. So by having this strong root, you can do this and you can replicate many chains. So we can use OBFT for Yella, we can use OBFT for EVM, but here's where it gets really wonky. You can use OBFT for Plutus. Why? Well, Cardano can be a side chain to itself. So you can run a high efficiency model, and you can even have different models. Like, for example, people like DAGs. They like these block trees. They like graphs. They like all kinds of crazy stuff about how to handle blocks in parallel. And in fact, we wrote a paper called Parallel Chains. Okay. And there's a lot of follow-up work there. There's a paper called Prism, which actually talks a lot about this by Pramod. It's not to be confused with our Prism paper, the Swanath. And it talks about actually how to create parallelism. So you actually do all of these things at the same time. All right. So having this heterogeneous model with stake pools as the root of trust that are always increasing means you can use them to replicate new chains, new resource models. It's a win-win for them because guess what they get? They get more revenue streams. They make more money because they're actually running multiple pieces of infrastructure and lots of parallel transactions and so forth. Okay, so that's the point. That's later in the spiral. But the point is that the spiral, each step of the way, is secure And each step of the way doesn't cause a mass disruption. And we just kind of grow on the spiral. And what happens is you get faster and faster and faster. So, for example, Mamba, the plan about sidechains that we've been pushing, that is running concurrently with Hydra, which is the other scalability solution, the layer two scalability solution, which is running concurrently with an optimization plan that we have to basically compress some more things and speed up some things and increase block sizes and so forth to improve the performance on the main chain. And that's running concurrently with Blue Ocean research, like, for example, concurrent state machines. And what's really cool is what's going to happen is all of these solutions. So there's right now 8 development companies we got together. And I think 7 of them are going to be presenting at the conference. And we asked them, go build a DEX. Okay. And go build an Oracle and go build a lot of different stuff. They're actually going to be showing their code, show code, and doing tutorials and talking about their experiences. The good, the bad, and the ugly. Okay, so that creates a feedback loop. And that feedback loop basically gives us more ideas about new features. So, for example, you'll see in Ergo, they have this concept of read-only UTXO. That's an idea. And there's dozens of potential new features. You could do pre-processing to actually take some of that processing that would be done with off-chain infrastructure for ordering and batching. And you actually could put something like that into the SPOs. Okay, so there's a feedback loop that now exists with the thousands of Plutus pioneers and the companies that are actually building on Cardano where we can add them. And, these two things, this one and this one, it's about 6 to 12 months. So about 2 to 4 HFC events because we average an HFC event every quarter. I think there's going to be 3 this year, but we'd like to get into a habit about 4. So there's, 6 to 12 months of taking it for a spin. And what will happen is you have all these people that are just so dishonest and just toxic assholes who say, well, what Charles is saying is Cardano won't be useful for 6 to 12 months. No, I didn't say that at all. At this juncture right here, you guys can do pretty much anything a Turing complete smart contract can do. We're going to have stable coins materializing. We're going to have interoperability materializing. You can do all kinds of locking mechanisms for multi-sig. You could start connecting centralized off-chain infrastructure. In fact, DC Spark is planning on doing that. You can run complex financial contracts, and we're actually a pretty efficient system. And all of our benchmarking shows about 2 orders of magnitude cheaper than Ethereum right now. And this month, those things will be solidified. And absolutely, there's going to be some creative decisions that have to be made with oracles and dexes. And partners have already started making some of those creative decisions. And those things will work their way into production this year and next year. And are they super efficient? Of course not. Why? Because it's a new model. No one has ever done extended UTXO before and Plutus before outside of Ergo. And at the scale we're doing it, no one's ever done that before. The point is that you want to establish a stable root of trust. That's what we've done here, and have enough programmability at the settlement layer where you can get people connected to the domains that they want to be and also move large amounts of value efficiently. You can represent and move value efficiently. Okay, that's why we created Marlowe. You see, Cardano is going to be, in our view, a dominant platform for lending, for insurance, for bond issuance, for all kinds of financial products. Now, when you talk about rich interactive experiences involving millions of concurrent users, blockchains are not built for that. Ethereum isn't built for that. Cardano is not built for that. That's not the point of these types of systems. You need bespoke domains for those types of systems. And those bespoke domains all have their trade-offs and their assumptions about how they run. If you're really clever about your design and your model, then what you can do is you can use the fact that you've created a very strong root of trust to instantiate those bespoke domains with different economics and different ideas, and then suddenly you can utilize them. But what's really nice about that is this concept of encapsulation. So, not every one of these bespoke domains will be successful. And let's say one of them collapses or has a problem or a flaw. That doesn't cascade back to the main chain. So, the billions of dollars of value that's on the main chain and the settlement layer is never really disrupted. You say, but Charles, well, what about the fuel source and things like? Well, guess what you can do? You can say, okay, well, the same mechanism that allows token locking, the same mechanism that allows staking, the same mechanism that allows voting, you can use this to generate an alternative fuel with different economics on the side chain. Okay, so sky is the limit. You can put in demurrage, you can put in, where the tokens